Refrigeration. Content. What is refrigeration? Theoretical process of refrigeration. Coefficient of performance. Refrigeration cycle. Basic components of a refrigeration plant. What is refrigeration? Simply, refrigeration is a method of cooling artificially, or the term refrigeration means cooling a space, substance or system to lower or maintain its temperature below the ambient one, while the removed heat is rejected at a higher temperature. Naturally, heat flows from high temperature region to low temperature regions. The reverse process, which heat transfer from low temperature region to high temperature one, requires special devices called refrigerators. Refrigerators are cyclic devices. The working fluids used in the refrigeration cycles are called refrigerants. According to thermodynamics, a refrigerator shown in the figure QL is the magnitude of the heat removed from the cold refrigerated space. QH is the magnitude of the heat rejected to the warm space at temperature TH. WH is the net work input to the refrigerator. Heat pump is another device that transfers heat from a low temperature medium to a high temperature medium. Further, the objective of a refrigerator is to remove heat QL from the cold medium. The objective of a heat pump is to supply heat QH to the warm medium. COP. COP stands for Coefficient of Performance. Performance of refrigerator and heat pump is expressed in terms of coefficient of performance. You can also find out how to express cooling capacity. What is reverse Carnot cycle and vapor compression cycle? Desirable properties of a refrigerant: high critical temperature, in which vapor cannot be condensed by isothermal compression regardless of pressure; moderate or low condensing pressure, to avoid built, heavy machines and plant scandalings and also reduce leakages; high specific enthalpy or high latent heat vaporization, to reduce the quantity of refrigerant in circulation, to lower machine speeds, sizes, etc. Low boiling point and reasonable pressure, otherwise operation at high vacuum becomes necessity. Low specific volume in vapor state, to reduce size and increase efficiency. Non-corrosive and non-solvent and good chemical stability under working condition to all material used in the system. Non-flammable and non-explosive, to avoid fire or explosion if leak. Easy leak detection, non-toxic, no hazard to health in case of leak, no reaction with oil. Refrigeration cycle. The refrigeration cycle begins with the refrigerant in the evaporator. At this stage the refrigerant in the evaporator is in liquid form, and is used to absorb heat from the product. When leaving the evaporator, the refrigerant has absorbed a quantity of heat from the product, and this is a low pressure, low temperature vapor. This low pressure, low temperature vapor is then drawn from the evaporator by the compressor. When vapor is compressed, it rises in temperature. Therefore, the compressor transforms the vapor from a low temperature vapor to a high temperature vapor, in turn increasing the pressure. This high temperature, high pressure vapor is pumped from the compressor to the condenser, where it is cooled by the surrounding air, or in some cases by fan assistance. The vapor within the condenser is cooled only to the point where it becomes a liquid once more. The heat, which has been absorbed, is then conducted to the outside air. At this stage the liquid refrigerant is passed through the expansion valve. The expansion valve reduces the pressure of the liquid refrigerant and therefore reduces the temperature. The cycle is completed when the refrigerant flows into the evaporator from the expansion valve, as a low pressure, low temperature liquid. Refrigeration system components. There are four basic components of a refrigeration system. These are evaporator, compressor, condenser, expansion valve. In order for the refrigeration cycle to operate successfully, each component must be present within the refrigeration system. The evaporator. The purpose of the evaporator is to remove unwanted heat from the product, via the liquid refrigerant. The liquid refrigerant contained within the evaporator is boiling at a low pressure. To enable the transfer of heat, the temperature of the liquid refrigerant must be lower than the temperature of the product being cooled. Once transferred, the liquid refrigerant is drawn from the evaporator by the compressor, via the suction line. When leaving the evaporator coil, the liquid refrigerant is in vapor form. The compressor. The purpose of the compressor is to draw the low temperature, low pressure vapor from the evaporator, via the suction line. Once drawn, the vapor is compressed. When vapor is compressed, it rises in temperature. Therefore, the compressor transforms the vapor from a low temperature vapor to a high temperature vapor, in turn increasing the pressure. The vapor is then released from the compressor into the discharge line. The condenser. The purpose of the condenser is to extract heat from the refrigerant to the outside. In ships, the low temperature cooling water, that is water from LT system, uses as the cooling medium. Inland it may be air. The temperature of the high pressure vapor determines the temperature at which the condensation begins. As heat has to flow from the condenser to the water or air, the condensation temperature must be higher than that of the water or air. The high pressure vapor within the condenser is then cooled to the point where it becomes a liquid refrigerant once more, whilst retaining some heat. The liquid refrigerant then flows from the condenser into the liquid line. The expansion valve. Within the refrigeration system, the expansion valve is located at the end of the liquid line. Before the evaporator, the high pressure liquid reaches the expansion valve, came from the condenser. The valve then reduces the pressure of the refrigerant as it passes through the orifice, which is located inside the valve. On reducing the pressure, the temperature of the refrigerant also decreases to a level below the surrounding air. This low pressure, low temperature liquid is then pumped into the evaporator. Filter dryer. These devices to trap moisture and other contaminants in a refrigeration system. Placed in either the liquid line or suction line. Oil separator. Placed in the discharge line right after the compressor to catch oil traveling with the refrigerant and return it to the compressor. Oil separator. Placed in the discharge line right after the compressor, to catch oil traveling with the refrigerant and return it to the compressor. Sight glass. Located in the liquid line to indicate the presence of liquid refrigerant, and sometimes also the presence of moisture in the refrigerant. Thanks for watching. Good luck.